Good morning. This session is around virtualized central office. I'm going to walk you through some work that was done as part of OPNFE. Initially, this project got started actually about a year and a half ago, where one of the providers, very large providers, actually it was AT&T, who came back and said, hey, we need an architecture for the central office that uses open source components as much as possible. And at that time, the Cord project that was being done by OnLabs wasn't open sourced. And that's kind of the journey of this, that's how this project got started. Now, Cord has, I'm sure all of you know, Cord stands for Central Office Redirector as Data Center. It's architected around the OnLabs work on ONOS controller and XOS as the orchestrator. And since that wasn't open source, people were looking for actually an open source alternative, and AT&T, along with a couple of other providers, started off this particular project saying, hey, maybe we should actually have an open source component of it. And we started discussing, going back and forth discussing, what should we do as part of this architecture and what should be the goals of this architecture. And it was much later. It took us about 6 or 7 months to actually just come around, agree on what we wanted to do, how we wanted to do it. And then finally, the whole project culminated in a demo at the OPNFE Summit in Beijing, where we actually showed what it means to be a virtualized central office. And so this presentation was actually done as part of that, as part of the demo in Beijing at OPNFE Summit. And what you see on this slide, the picture on this right-hand side, is the actual white paper that was published as part of the community activity. And this is about a 42 or 45-page white paper that goes into a lot of depth around what is a virtualized central office, what should its architecture be, what sort of services can you deliver, what are the deployment models to consider, and how would you go about building one. So that's kind of the nutshell and a background of this work. Let me just get started on, first of all, why. The goal, as I said, was to define a cloud-native approach to build a virtualized central office leveraging the NFV framework and open source technologies. And of course, why do you want to do that? Because virtualized central office is the interface to your customer from a service provider's perspective. So you want to be able to build better services, provide better service agility. You have to have, central offices are characterized by lots of different types of hardware. You want some level of operational efficiency across that. You want to provide better customer experience and, of course, drive your costs lower. In US alone, there are about 10,000 central offices. In China, apparently, there are more than 20,000 central offices. And central office, as I said, is a primary gateway to the customer. That's where as a customer, as a subscriber, your lines get terminated. That's where you get your local services delivered to you. And that's where generally most of the quote-unquote stuff happens. So, there was actually a very interesting picture as part of doing this presentation. I dug around in old Wikipedia. In Wikipedia, there was one image around a central office where you had this concept of a building which had these multiple different floors with different departments. And in one of those floors, you had these people wiring, connecting these wires from one place to the other as you actually made your calls on the phone. Well, of course, modern day central offices are very different. You have, copper termination, fiber termination capability, metro services capability, access services capability, and so on. But also in terms of how do you take your workloads and how do you, use purpose-built hardware and general purpose hardware in that environment and provide an overall service. So current status of central offices is, of course, they're a huge source of CapEx and OpEx for a service provider. They're very rigid, they're very complex, they have a wide variety of hardware that's deployed in there. There is lack of programmability, there's lack of standard interfaces, and you have different types of switches, gateways, routers, fiber termination blocks, transport devices, on and on and on. And the goal of these service providers, as I talk to them, is to reduce that particular CapEx and OpEx by more than 30%, operate in a flexible and a standardized environment, to build a la cloud model, and of course leverage the principles of software-defined infrastructure and provide some level of full programmability. So then when we started out on this journey of building this particular central office, there were some principles we had to stick to. And by the way, this was a community of 3 different providers, at least to start with, and then about 12 or 15 different vendors. We would have literally weekly calls to go through this particular discussion and figure out what do we mean by a virtualized central office? How is this different from CORD? Is this different from CORD? Are we actually trying to build another CORD-like equivalent model? So we went through a lot of debate. Eventually, we had a workshop at Open Daylight Summit in Seattle in November 16. November 2016. And in that workshop, we had a room full of people with all of the major service providers represented there, all of the major vendors represented there, and we had a giant conversation that lasted for more than 2.5 hours to go through, what should we do about this? So we agreed on a set of principles. So first of all, we said this has to be a white box architecture. It has to use white box switches. It has to use, available software, most likely as much open source as possible. Use OCP, Open Compute Platform, as compute and open storage capabilities. Have a single SDN controller as opposed to multiple layers of SDN controllers. So as you build your fabric, as you build your PNFs, physical network functions, as you build your virtual network functions, create a single SDN controller paradigm. Of course, virtualize those control functions, including things like OLT, ONT for GPON termination, or virtualizing the CMTS capabilities on control functions. Run those control functions as VNFs on the compute infrastructure. Of course, in the mobile case, it would be your SAE gateways, your MME, PGW, SGW, all of those characterized as SAE gateways. And then, of course, run virtual network functions, VMs or containers, doesn't matter. OpenStack as a basis or as a starting platform. Who knows where it's going to evolve in the future. An open orchestration model, so don't be tied to a specific orchestrator, a specific controller on the SDN side. Use ONAP if possible, use open source Mano if possible, use different onboarding techniques with Tacker, or perhaps even just Ansible alone. And then start off with VCO residential as to deliver a set of residential use cases. Then go to VCO business to deliver an a la SD-WAN model, and then move on to the VCO mobile. So we started off with this set of principles, and we said, okay, let's figure out what are the different architectural components that we need as part of that. So let's look at the infrastructure components. So what should be the fabric be? We got feedback from the team saying the fabric needs to be an EVPN fabric. So it should be all white box switching with BGP running in that particular fabric, built using EVPNs, Ethernet VPNs to do to build service chains and put these virtual machines inside a service chain to be able to deliver a service. The advantage EVPN provided was that you could actually extend that fabric, not just inside the data center or inside the central office, but actually tie it to the EVPN deployment model that exists in an access network or a core network or an edge network for a telco. So that was important. A virtualized infrastructure manager, OpenStack, and Kubernetes, so we discussed those. Of course, network functions, I think I talked about it. One of the architectural principles we banked on was to have as much a disaggregated model as possible. We started off with the disaggregated conversation. Obviously, when it came to demo time, we couldn't get an entire disaggregated conversation going because of availability of different sets of VNFs, and I'll actually talk to you about those VNFs in a moment. Then Open Daylight was automatically chosen as the SDN controller, and we wanted to be able to do that using Open Daylight controller, and then do orchestration, onboarding, management of the infrastructure, and build that entire service end to end. When we started off with that, Open Daylight did not have EVPN capabilities. at least as per Carbon release, and it was before Carbon, that is when we started this project. So there was no EVPN capability in Open Daylight. Then we had a hard time trying to find an OS that could run on white box switches that supported, EVPNs. So anyway, when the last time we met was actually in the in-person meeting. We had a workshop or a meetup at the Boston OpenStack Summit. That's when things started to come together. We said, yes, we think we have all the components in place, and let's kick off this activity. So a week after the Boston OpenStack Summit was when we had vendors sign up to do this, and we started driving that project. It took us around 3.5 weeks to complete the whole project, show this demo live at OPNFV Summit in Beijing. So I'm going to go through the different use cases, and I'm going to probably also show you some recorded videos from that particular demo and walk you through what we've done. So there were two things that we banked on as part of the demo or as part of the first POC for VCO. One is the enterprise VCPE, and the other one was the residential services. So creating a full residential services from subscribers to the BNG and access concentration. And on the enterprise VCPE, trying to show a typical collapsed branch type of model where you can have a CPE that runs a bunch of services on that CPE and is able to access across a wide area network. So that was the main aim. We wanted to get different open source VNFs, as many open source VNFs as possible. We couldn't get as many open source VNFs. We did end up using firewall, virtual router as open source VNFs. Then we had a whole bunch of vendors bring their own sets of VNFs to actually be part of this exercise and show this particular proof concept. So firewall and virtual router were the two. The rest of them were all vendor provided set of VNFs. Then Lenovo was kind enough to actually loan us their lab facility in Raleigh, North Carolina. We started to stack up the servers in that particular lab, make that a central office. And then we had all of these 12 different vendors, 20 different VNFs, everybody trying to access the lab remotely. It was such a chaos. But that 3.5 weeks was something that we learned a whole lot through actually proving this particular concept for both residential and business services. So we did that. We had a branch emulated in the Lenovo lab for a branch office for the enterprise use case. We had a bunch of VNFs shown up from different vendors on BNG, on firewall, on DPI, on policy, and on and on. So let me just walk you through a little bit of demo. So by the way, that's the rack of equipment that we ended up using. You can see a mess of wires there. That's OCP hardware, by the way, if you notice from the picture on that right-hand side to the far right on my side. That's OCP hardware that we ended up using. And then, there were a bunch of switches. You can actually see some switches on top. Those switches are Mellanox switches. They are white box. We actually weren't even running the Mellanox software on those switches. We ended up actually running Cumulus software on them because Cumulus had just released EVPN capability as part of their software. So we ended up actually running Cumulus software on those Mellanox switches with Lenovo OCP servers sitting there. There was some general purpose servers, also GP servers that were used as well because we kind of ran short on hardware. And I'll actually explain the pictures and the architecture and so on. This was the architecture that was actually developed as part of the white paper exercise that was done with contributions from many different people. I lead that particular working group, and one of my colleagues, Pazzi, who's been my partner in crime in terms of defining this particular architecture, defining the various different interfaces. There are some new interfaces we ended up defining in terms of particularly where the Open Daylight connects into different sets of, or manages the fabric and manages the different sets of VNFs, and also some new interfaces in the context of Tacker or generic VNF manager connecting to the fabric itself. So you can see some new interfaces there called NNMC, FNMC, or FN, down here at the bottom. That one, and then there are a couple that are defined in red. Those are, again, part of that particular architecture paper. I can walk anybody through if you're interested in understanding what that is. But one important point was to use an end-to-end orchestrator, leverage existing OSS BSS systems, make this as much open source as possible, and use a common model for both physical network functions and virtual network functions. That's the software stack we ended up using, and these were all the different vendors that were part of our first POC: Cisco, Ericsson, NetScout, F5. We ended up using open source VNF on Viata OS and pfSense. I didn't have the pfSense logo there. We used Red Hat OpenStack platform. We used two different kind of servers, one on Lenovo, the other one from Nokia, both OCP. We ended up using Mellanox switching, switch fabric. The switch fabric that we used was 1025 gig. So 10 gig towards the servers and 25 gig towards the spine switches from the leaf switches. And we ran Cumulus software on it. And with Open Daylight Controller and the standard OOO installer for the OpenStack. So that's what it looked like with 2 spine switches, 3 leaf switches. There were a bunch of OCP and GP servers that we ended up using for compute. And because, again, we ran into problems with some of the OCP servers. We had some firmware issues on some of the servers. So we had to literally go searching in the Lenovo lab for more machines because we had literally so many different VNFs. And these VNFs weren't small. I mean, if you take a look at the BNG that came from Ericsson or from Cisco, it required a lot of CPUs. It required a lot of memory. So they weren't small by any means at all. And we had storage that was required to store all of these images, move those virtual machines around. We had to simulate some small tests where we had a failure. So what would happen? How much would it take for a machine to move from one place to the other, and so on. So that's and then we had a jump host through which you actually would come in, go into the fabric or go into those VNFs. Because there were so many vendors working at the same time, the way we ended up doing was actually creating an AZ availability zone in OpenStack for each one of those vendors. There's also intellectual property issues when you have a Cisco supplying a VBNG and an Ericsson supplying a VBNG. You don't want the Cisco guys to look at Ericsson VBNG and figure out what's going on over there. The spirit of cooperation was great, but it's still at the same time, different vendors are a little bit apprehensive in terms of what they want to share and what they don't want to share. So at least as part of the onboarding process, what we had to do was give each and every one of them an AZ and say, go onboard in this particular AZ, right? And so they ended up onboarding their particular VNF. And then once the VNF was available, then we could stitch them together into a service chain and actually go deploy the service end to end. So it was actually quite interesting. That was the topology. Then we had a server up on stage in China when we actually did this particular demo. That was from Nokia. That was emulating another branch that was talking over internet, VPN tunneling back into the OpenStack VNF router, virtual router that was there in the OpenStack install in the central office, and then from there being mapped onto a branch, VLAN that's connected down to that particular server that is emulating another branch. So that was kind of the setup in terms of creating. So you needed an automatic setup. Literally, we booted the server on the stage, and when the server got booted up on the stage, it would bring up, connect automatically back, bring up the VPN tunnel, and then you could establish the connectivity and see that, okay, here's a way to remotely provision a branch, bring that up, get it running, and be part of a complete business service. That's just the Horizon screen in terms of the different instances. Actually, I had some other pretty pictures, but I'll probably spare that for the moment. This video is also posted on the OPNFV website. This is the picture. You had, initially we started off with a virtualized OLT from, between the ONT, which is optical network termination that is on the subscriber side, to an aggregation point, which is the OLT that sits in front of the virtualized BNG. We couldn't get that OLT shipped into the lab in time. So while we tested the OLT first remotely from a emulated instance, we couldn't get that shipped into the lab. So actually, when we ended up showing the demo, we just had standard, PPPoE authentication and IPoE authentication for both Cisco and for, Ericsson BNGs. And so the Ericsson BNG was terminating, PPPoE sessions, and then you would service chain a DPI VNF, a anti-DOS protection VNF from F5, and a vRouter with that particular vBNG using EVPN and using Open Daylight and control that. And then we had, just to test another data path, we had ended up connecting the Cisco BNG to a different data path just to show that we could actually do both of those from the Open Daylight and actually manipulate the EVPN fabric and the set of connections. So on the business services side, this is what we ended up doing, which is you had that box that you see is the OpenStack install with a bunch of VNFs that go there. You have a VPN tunnel that's terminated, that's coming in from China. We had actually some interesting challenges trying to create that VPN tunnel from China because of the Great Firewall of China, right? It was quite hard to actually get that to set up because it was a learning firewall, we had to do some tricks. Even literally until the last minute before we went on the stage, we were still tinkering with the configurations. But ultimately, it all worked out. It was all done in good faith. So on this particular server, what happened was you boot this particular server on stage. You provide the connectivity. This is, by the way, a recorded video on the OPNFV website. You can actually go take a look at it. One of my colleagues actually does that. He connects it. The server comes up. It then establishes in VPN Tunnel, gets the information from the central office where we have a policy provision. It downloads that capability and says, okay, now I'm established as a branch. And then we could show that there's connectivity across from the stage all the way to that particular. We were hosting a bunch of applications on that VCP on the far side there to show that there's intranet connectivity across. What I'm going to do is switch from here to a little video. Bear with me for a moment. So I'm going to just do a little bit of a pause on this video as well. Let me just actually. Okay, so what this video does is it walks you through first the onboarding process. There's a bunch of what we ended up using eventually. Again, we wanted a flexible model. Everybody was comfortable with using Ansible to be able to do that. We used Ansible. So in this picture, I'm sorry, the information is pretty small and it's an eye chart, but all of these configurations, all of these topology, everything is documented. It's posted on OPNFV website, and it's cataloged in a GitHub repo. So anybody want to be able to go take that, replicate it, you should be able to do it as long as you have access to the images of those different vendors with respect to the VNFs. As far as Red Hat goes, we can provide you access if you're interested in doing that. So these screens, now you'll actually quickly see through the Red Hat OpenStack platform, and these screens run pretty fast, but this is getting all the VNFs onboarded across. You can actually, I'm just going to keep pausing momentarily here and there. Now this process, in this particular one, we are actually onboarding the Ericsson vBNG, and so you can actually see, jump host, from VCO jump host, you're going into the Ericsson, okay, you're trying to get the VNF onboarded. At some point, now, we actually look at the VNF. There are multiple instances of that. Is it running? You can actually look at the console, and now you can log into the vBNG and say, okay, show my vBNG. So the way Ericsson vBNG works, just for clarity, is it has a control VNF, and then it has a control VM, and it has two data plane VMs. They all work in combination, in concert, as a complex VNF with 3 different virtual machines. And so you can actually see that, these are some show commands for the Ericsson VNF, and you can do this. The next step is to onboard F5 Anti-Ddos Vnf. Now you'll see that initial configuration. This is the F5 screen. It's all empty. There's nothing there. And by the way, they're using Ansible to onboard. Again, for them, it was a lot easier to do that. So there you go. Here's you can see that YAML file in terms of what's coming up. And you can see a whole bunch of, Ansible, being executed there. Here's the way. Ultimately, it comes back and says, OK, that's onboarded. And you can go back and look at the F5 screen and say, OK, I have those VNFs that are showing up in the Ansible tool. So similarly, you can go do the same thing for DPI VNF. I'm just going to let this particular script run, and then you can actually go see that the DPI VNF is up. That was kind of the topology we ended up with in the OpenStack Horizon dashboard. You can see the number of different VLANs, number of different VMs, so many different provider networks. It was quite a complicated setup. But to actually be able to do this entire thing in 3.5 weeks from scratch, from the time we got our hands on the hardware to the time we were actually able to show live on the stage, it was the time, elapsed time was 3.5 weeks. Of course, we were working, multiple different teams were working, pretty hard to get that all onboarded and done. So that's what the topology kind of looked like. Sorry, it's a little bit of a mess. And now we start to actually define that particular end-to-end service. So what you will see first is, subscribers authenticating to a virtualized BNG, and then the BNG, passing particular traffic. So you're running a command that essentially brings up the PPPoE interface, and once you bring up the PPPoE interface, it's ready to authenticate, and you see that PPP interface is up right there, and now you'll see that a request that will come in, and there. Now, as a user has been authenticated, you're able to now reach through the BNG out into the internet. So that's again, sorry, it's a little bit geeky. It could have been better, but given the time we had, that's probably what we could do. Now I'm going to show you something very interesting we ended up doing. So one of them is to define a social media policy. So if you can define as part of the residential policy setup that you have a social media policy that says no access to Facebook, as an example, right? You should be able to do that and be able to show that, demonstrate that over here. So first we're going to reach out to Facebook initially to show that everything's okay. Facebook's been found, 302, that's right in the middle, everything's fine. The connection is available. Now what we're going to do is actually execute the policy using an Ansible playbook. So right there on top, you'll see that here's a playbook, and in that playbook we're defining that social access to social media should be denied. Now that Ansible playbook is actually going out and configuring the DPI VNF and the firewall that's there. And so these are, if you remember, I showed you earlier on, those were F5 VNFs. And they are, instead of using the F5 config tool to go define that particular policy, we used Ansible to go define that particular policy using a device module for F5. And now that playbook is executed, okay, let me just pause there. Okay, there you go, the playbook is executed, and that's all done. Now you do, again, go back to the previous screen and do a curl onto the Facebook page. So when you do the curl onto the Facebook page, you see there, it says, I'm closing that particular connection because you don't have a policy on that particular page. You cannot access that. And I'm going to redirect you to a captive portal that's there that says captive location, mycaptiveportal.com. Right? So now you can see that just by using an Ansible playbook, you were able to execute, make a change, make a policy change on the VNF, and then you can see that the traffic's moving. Now, what about the secure traffic? What about HTTPS? Do we allow that as part of the same policy? Well, you can do that. So likewise, this is another demo where you have a very a high-speed download that's occurring, and then suddenly you will see a denial of service attack that's happening for that particular subscriber. So notice on this right-hand side, right on top over there, it says 575K on top. So that's kind of the speed. So that's the speed with which something's being downloaded. We just downloaded an image, and you can see that particular speed, 615, and now it starts to go down, because what happened was at the bottom we initiated a flooding of packets on SYN packets, right? So when we did that, when you did a flooding of those packets, ping packets, you will see that speed actually started to go down. So now it's detecting that there's a denial of service that's actually happening, and you will see that speed went down from 525 or 612K down to 5K or 7K. All right? Now, after some time, now it's down to 2K, 1K, and now it starts to increase back up. Because what happened was that DPI VNF looked at it, hey, there is a denial of service attack that's happening. I'm going to start throttling this particular traffic down so that my actual traffic can come back up. And so now you can see that it's increasing back up again. And again, this particular configuration was all done through standard tools, Ansible, and so on. So that was on the residential services side. Let me just go back to my presentation. I'll just walk you through the last component of service assurance, and actually walk you through one more. Pardon me, what's going on? Okay. So it's not just about showing a service, but it's also about showing, how do you do service assurance with that particular service? How do you do correlation of capability? What sort of VNFs do you need, and how do you actually, make that an end-to-end? So we used the OPNFV barometer project. Intel actually did some work with us on this to make that happen. The idea was to actually take the information on the servers in terms of utilization of CPU, memory, and so on, map that and actually be able to plot it real time, provide that particular information to see how hot a particular node or a host was running, and then move those workloads around based on that on that usage. So really demonstrate how you can monitor those capabilities, how you can provide the relevant set of metrics, and do that. So what we ended up doing was at every compute node we installed a collectee on each of those hosts. The collectee collects information, and you stream that information using telemetry back into Grafana and InfluxDB, and then using Grafana you actually plot those charts to show you what that usage is for each one of those locations to find out if a node is running hot, and if the node is running hot, how do we start to now evacuate that particular virtual machine or VNF and move that virtual machine over to another host that is available. So you can see on compute 0 the three different virtual machines, VBNG 1, VRP21, VRP22, they belong to a single VNF. So when you start to evacuate those virtual machines, you need to figure out that if there was a VLAN dependency that was there between those virtual machines, they're all operating as a complex VNF. So you have to actually worry about, suppose VRP2 was running hot as an example. And if VRP2 is running hot and my CPU is actually spiking on that particular compute, I need to move VRP2 out of that particular compute host into a different compute host. So you had to then now create network extension using Open Daylight Controller, make sure that that network extension is applicable to a different host, then start to move that particular virtual machine out to a different host. So it was all these complexities and intricacies that we had to work through. And then we ended up using something like NetScout to actually correlate all of those different capabilities in terms of the alarms on different. So what NetScout did for us was watched all of these capabilities. When we were plotting using the OPN, the barometer stuff, and then correlate that information to say, oh, when I'm evacuating this VM and I have a failure or I'm running hot over here, here's what here's what it really means, and translate that message. I'm going to just quickly show one more video in the same way as the other one, and then we'll wrap it up with a summary. We are pretty much on time. So just give me 1 second here. Right here. Okay, so similar to the previous video, what we're going to do here is do a compute stress test. So you're doing a collect D service. You're going to start this collect D service, and now you're going to stress the CPU by just running a few. There's a little utility that you run, and you say, okay, I'm going to consume this many CPU cycles, and I'm going to consume this amount of memory. And now you can actually see that some of those graphs change in real time. Now you can go back to the residential use case. Once the residential use case was running, you can actually go look at those particular graphs in terms of how, what the utilization is, and then take that information and use correlation capability that we had with NetScout to show that you have an end-to-end service that's really actively available or working. So this video kind of goes through those sequence of steps in terms of various different things. You can see here's the forwarder. This is the one, now it's running pretty much at peak. And then what we do is we actually end up evacuating it. You see the VRP2 and VRP21 and 22 that I was talking to you about over there. And these are all stats that we're collecting in a streaming using telemetry in real time, and then acting upon those stats to actually move those virtual machines around. So that brings me to almost the end of my presentation, which is here's a quick summary. So virtualization of central office, the goal was to build a common architecture with this highly flexible, use any orchestrator, use a standard SDN controller. Also to demonstrate that OpenStack as a platform can be mature, you can run different kinds of workloads on this. We also started to incorporate open source VNFs as part of this whole exercise. And OPNFV actually provided us that particular umbrella. Since this project was done, we've now kickstarted a VCO mobile project, which is to cover the mobile aspects of a virtualized central office with 5G vRAN as the first step, working with China Mobile in this. So the proposal has been submitted to the OPNFV to start off an official project. We are now in the planning phase. Our goal is to create a VCO mobile, a similar POC sometime early next year. And the goal is to actually look at the full vRAN capability, from CU, DU, as well as a virtualized BBU with the full packet core, initial LTE packet core hosted on the OpenStack platform, and work through that. So then another ask that we have had is to do ONAP integration with that, and to add things like MEC, mobile edge compute, or an IoT gateways to that particular conversation. We're looking for more participants, obviously, as part of this effort. It's going to be a big effort. Our target is to try to demo something closer to the next OpenStack Summit in Vancouver. And you should, if you're interested, you should join in. These were all the set of people who worked on this particular project to make it happen. A lot of people from different companies spent a lot of time to show that this is possible. With that, I'd like to thank you for joining me for this particular session. If you have any questions, I'll take them now. I think we don't have a lot of time left, so I'll try to keep it short if there's 1 or 2 questions. Otherwise, I'm available always afterwards. Yes? Yeah, so Cord is still continuing. Cord is now owned by Linux Foundation. However, they're still focusing on Exos and Onos as the Onos as the SDN controller, Exos as the orchestrator. I do believe there are some people who are interested in deploying Cord, so I think that will continue. But majority of the conversations that I've had with different customers or different providers, they're interested in seeing an open approach, and hence that was a motivation on this. Again, power to them for doing what they did, because they started off, they started this whole concept of virtualizing a central office. And I think time will tell us in terms of who will end up deploying what and where. Any other question? Yes?
For bringing up Cord, Cord we can download from the internet and test it out. Can we try that?
Yeah, so we have posted all of the scripts, all of the capabilities in a GitHub repo. The link is on OPNFV website. You should be able to go there and get all of the information in terms of onboarding process, configurations, what we did, how we did it. The difference here was that we used different vendor VNFs, and so you will have to have access to those VNFs. Some of those open source VNFs are all provided, again, in the GitHub repo. The ones that are not open source, like the Cisco and the Ericsson and so on, you'll have to actually talk to those vendors to make that happen. Our goal when we go to VCO Mobile is to see if we can use an open source SAE gateway, and then we can post even those in the GitHub repo and get that done. So I'm sorry I'm out of time, but thank you so much. I appreciate you joining.